All right, so today we're going to be talking about Chapter 8, Lesson 2. This is all about the area of circles. So when we have a circle here, we want to make sure that we have radius. If we don't have radius, we need to find it. So if you recall from yesterday, the radius, we can either say it's 1/2 the diameter, or we can say it's the diameter divided by 2. If you recall that from yesterday, or last lesson. Now, when we find the area, normally we find the area by multiplying the length times the width. The only problem is, with a circle, the only dimension that we know is the radius. So we're going to utilize that, because if we look at this, the radius, and if we look at the radius going up here as well, we can actually kind of make a square out of this to make it look like we have some kind of sense of a shape that we can actually find the area of. So if I go ahead and use a purple pen here, we can make a type of square like that. And if we were to continue this all the way around, like so, so we have a square that takes up 4 of these smaller ones. So again, we have another one coming down here, another one coming up here. So right now we have something that kind of looks like R times R, so this is a square, and it looks like it's nearly 4 of them, but it's not quite 4. So we're going to say the area is radius times itself, and nearly 4 of those. The thing, though, is nearly 4 isn't anything very specific. We need to have something very specific to help us. If you recall from Lesson 1, we had this number called pi. Pi was about 3.14, or we could approximate it as 22/7, which again, that's a little less than 4. Which should make sense, because each one of these, even though this entire square here is r squared, and it's 4 of them that I have here, we're taking off, it almost looks like a third or maybe a quarter of each one of these squares is being taken off. And in fact, our formula, area is radius times itself, so that's r squared. And the number that we're going to look here for nearly 4 is actually going to be pi. Now again, pi can be either 3.14 or 22/7. Either one is going to be a great approximation. So let's go ahead and start looking at some examples. Example 1, it says find the area of a circle. It has a radius of 4 centimeters, and it says to use 3.14 for pi. So I'm going to utilize this formula right here. A equals pi times r squared. So r is 4, so I'm going to substitute 4 centimeters for r. And it says to use 3.14 for pi. So I'm going to substitute 3.14 in for pi. So now I have 3.14 times 4 centimeters squared. Now, on a calculator, it's kind of hard to find the square button, and that's okay. But what square really means, oops, go back, is times itself. So we're going to do 4 and another 4. So this number is going to be 50.24. Now, centimeters here are units, but we multiplied it in both directions. So we multiplied it in this direction, and really in this direction as well. So because we multiplied in 2 directions, we're going to have centimeters squared. All right, example 2. This one says to find the area of a circle with a diameter of 14 meters and to use 22/7 for pi. So first of all, we have diameter. We want to find the radius. So I'm going to take the diameter and divide it by 2. So I have 14 meters divided by 2. So the radius is really 7 meters. So now I'm going to utilize my formula. A equals pi r squared. I'm going to substitute 7 in for r and 22/7 in for pi. So it's going to be 22/7 times 7 meters squared. So if I utilize my calculator now, right here on this calculator is the parentheses. So I'm going to use the parentheses. So 22 divided by 7, close parentheses. And I'm going to multiply by 7 twice. Showing your work here then would be the same as 22/7 times 7 and 7 again. So if we look at this work here now, these two 7s can simplify to 1. So now I have 22 times 1 times 7. So this number should be, I look at my calculator, I have 154. So the area is 154, and the units are going to be meters squared. Example 3, it says find the area covered by the fountain. Use 3.14 for pi, and in this case it says to round to the nearest tenth. So my diameter is 5.2. So I need to find the radius first. So the diameter is 5.2. So my radius is really going to be 2.6 meters. So area equals pi r squared. Using 3.14 for pi, so I have 3.14. The radius is 2.6 meters, so I'm going to do 2.6 meters squared. And again, when we square a number, that means we multiply it by itself. So 3.14 times 2.6 times another 2.6. And that equals 21.2264. We want to round to the nearest tenth though. So this is going to be 21.2 square meters. And these are approximations. Because again, we are rounding and using approximations for pi. All right, let's look at the backside here, because now we're going to be talking about semicircles. Now, if you look at this, this is half of a circle. So the area of a semicircle is going to be half of a circle. So the area is 1/2 the area of a circle, which happens to be pi, again, and r squared. So let's look at example 4. It says find the area of the semicircle. Use 3.14 for pi and round to the nearest tenth. it gives us diameter. So I need to use the radius, I need to find the radius. So diameter is 9 centimeters. Divided by 2, the radius would be 4.5 centimeters. So let's use the equation here. Now we're looking at a semicircle, so we want to use this equation here. So we have A equals 1/2 pi r squared. It says to use 3.14 for pi, so I'm going to substitute 3.14 in for pi. And I know that the radius is 4.5 centimeters, so I'm going to substitute 4.5 centimeters in for r. All right. Now, on a calculator, we can do this, but 1/2 is 0.5 times 3.14 times 4.5 and 4.5 again. So we get 31.79. We want to round that to the nearest tenth. So if I look at this, I'd have 31.8. Because we're rounding here, we have to look at this number. And this number is 4 or 5 or more, so we have to raise this one up. So this would be about 31.8 centimeters squared. All right, that's going to be the end of lesson 2. If you have any questions, please let me know.